Where's Thomas? Thomas is the one that wanted to. Did I invite him?
He's hopping in.
Okay, because I think he says yep, one sev.
Before we start, thanks Camille for Friday's debug session.
Let's just wait till Thomas gets here. Because I think one, Camille, do you remember the, does everybody have a link to the document, first of all? Yeah. Good. Hey, Thomas.
Hey, how's it going?
Good, how are you?
Pretty good.
Awesome. So we have Camille, the expert here. I wanted to start with some of the issues that you were having with the CI that you feel that we should use Airflow for as an alternative because we just can't do them with CI. And I want to write. There's a link to the doc. You probably don't have it because you came in after. I'll just
yeah. Oh, okay, I'll pull it up. Thank you. Let me pull up another one that I have. Sid. I'm looking at this one as well.
Okay, so can you explain what you mean by multiple pipelines?
Yeah, so basically being able to run stuff independent of other things. So like right now we have a very rigid, everything gets extracted, everything gets transformed, and eventually it'll be, I guess, extract, load, transform. So having multiple pipelines means that like something can fail in the extract stage. So like Zora can fail in the extract stage and it won't prevent SFDC from running all the way through transformations, right? Right now, everything is very tightly coupled with each other, and that's just not good design because that means the extremely flaky stuff like SFDC is constantly going to be breaking and preventing other stuff from running, right? So now, if we have something like SFDC failing, like we're punishing other data sources that would have run just fine.
And just to make sure I understand, so, obviously we can make SFDC allowed to fail.
Mm-hmm.
At that point, like the extract job will continue. But to maybe understand better, your ask is maybe to separate the DBT steps for SFDC for usage ping, like. So,
yeah,
so then,
well, sorry, go ahead.
I was gonna say, like, so the idea would be have like the extract FCC step, and then like that could fail, and it would then like stop the DBT FCC transformation step. But it would the rest of it continue.
Yeah, exactly, right. Like SFDC should only be worrying about SFDC, right? Like that should have no ties. Another example is, say SFDC job takes an hour. Just for example, I have no idea. Marketo takes 10 minutes, right? You can't get to that DBT step for Marketo until SFDC has finished running after an hour, when really maybe Marketo was done in 10 minutes and could have gone on and run its DBT stuff, and whoever was iterating on that could have seen that faster, right?
And obviously we could solve this by jamming the DBT step for each extractor into the same job. But that's
exactly,
really,
but then you don't know where the job actually fails without actually going and looking at the logs, right? Because you still want to have those tasks separated, like they're logically different. And I mean, yeah, like we could do that, but that's just a Band-Aid on a bigger issue.
Right.
So yeah, the idea is that we have these multiple jobs that are running, like SFDC and Zora, and they're tightly coupled right now. meaning that if one fails, the whole enchilada fails. And
Correct.
even if we allow them to fail, it's not really the point. It's more the point that they're tightly coupled.
Yeah, exactly. Because then the issue on top of that, like Josh said, is, I mean, say you have SFDC fail, but you allow it to fail, and the next step you're still running that DBT SFDC job. It has no idea that SFDC failed, right? It has no way of knowing that. We can't pass that and tell it, oh, SFDC failed, so don't run. I guess you could with an environment variable, but at that point, it's still just Band-Aids.
I mean, we could seriously hack that and then Camille.
Yeah, exactly. I'm sure we can hack a lot of things.
By having like an artifact persisted on success of the SFCC job and then reading the artifacts in the following DBT job to see which ones actually succeeded or passed. But again, we're getting into like seriously hacky territory.
Yeah. I mean, everything's fixable with a hack, right?
Well, also, in my talks with Sid, what he said is that what we should try and do is see what are we actually missing in CI, and then we can take the steps to help Camille build it. This is what this is what we can do. But the question is, like, are we actually? So Camille, do you understand like what we're saying, that we have like two jobs and they're both running? One can fail. We want to know it fails, but we just don't want it to kill the other job. We don't want all the jobs to be tightly coupled together like that, if that makes sense.
It tells me like I have some vague understanding of like how it's supposed to work. So Thomas, if you could like maybe show me like in more detail like what we want to achieve, because like I look at this doc and there's like a lot of keywords in this doc, like multiple parallel pipelines, DIGs, retro logging, and things like that. But like I understand that this is needed, but it's really hard for me to understand why it is needed without knowing exactly like how we process, and how it differs from like what we offer today.
Yeah, and I think that's kind of an inherent thing where CI doesn't make a whole lot of sense, right? Because normally when you run CI, everything should pass, right? Like you're running CI for that project. To put it simply, like what we would want is basically pipelines, like without having to break all of these data sources out into their own repos. They should all be able to have their own. I don't know if that's like we need to make different CI files, but if you think about a DAG, right, which is currently pretty much a canonical way to deal with data infrastructure, you would have a DAG for every data source, and even within those data sources, every table, right? So maybe we're loading a certain SFDC table, and it breaks. That's okay, because all the other tables can run in just fine, right? Everything is broken down to the smallest unit possible, right? Whereas now we're breaking everything down into steps, right? So all the extract steps are tied together, and if one extract step fails, they all fail. And we would like to have them, if one fails, the rest can still run. But then, like Josh and I were talking about, then the next step where stuff gets loaded, we want it to be aware of that as well. And I think the multiple pipeline issue, like if you added in DAGs, I guess this might just get fixed inherently. But sorry, go ahead.
I was going to say that a DAG would address this particular problem, because you could have you could have like parallel.
Do you know what we mean by extract steps and all that stuff, Camille?
So basically what I don't understand so far, it's like we have some data source, we basically extract that into our null representation, and like it can be like multiple sources, so it's kind of like map and reduce, right, approach that in some cases we may not have like data source available for us because it's broken, but we still want to process like every other data that is currently present, to not have like the gate process that if something is missing, everything is not working.
Yeah, exactly. Yeah, so we basically want more. I don't know, just more modularity, more independence, right? We don't want things so tightly coupled together. We basically want each table or each data source to be its own thing, right? Yeah, thank you, Jacob.
Yeah, so I was thinking we could just share, just Camille, for your benefit, what the current pipelines look like. So basically, we have these extractors for all the different sources that we have. So Marketo, NetSuite, Usage Ping, Salesforce, Zendesk, or etc. And then we have a single job for DBT, which then does transformations on some of these sources. And the transformations being basically making it more usable for Looker and other changes. Yeah, so the ask here, for example, would be, FGCC should have another job after it for the transformations for FGCC, but and that way, if this job fails, you don't run the transformations for FGCC. But right now, obviously, if any of these fail, the whole pipeline stops. An alternative is to make it allowed to fail. Yeah.
So basically, this is about the architecture of the pipeline, because pipeline is by the definition staged process. How about execution? Is it something that is being run continuously, or is it something that is being run when on a click?
It's being run every 2 hours right now on a scheduled job.
So is it it does fulfill the requirements, or this is something that is also lacking?
Is what a requirement?
And it's okay that it runs every 2 hours, or it's the intent for it to run continuously?
I think every 2 hours is fine. I think normally it's like a kind of like a periodic batch job that you run.
Yeah, the batching is totally fine.
We're not doing real-time streaming out of these sources. I don't think they support it. So you kind of have to periodically check in.
But that's also a requirement that some jobs may need to run every 1 hour. Some other extraction jobs may need to run every day. Some other ones may need to run every 8 hours. So we want to have a lot of extract jobs, bring data. Depending on the source, you may need to go have something like 50 extract jobs there. So all running in parallel. And what Thomas was discussing was maybe this DBT model will be tied to each extract job. So split to 30 smaller DBT models, mappings, that will be specific for CI stats, specific for level, for Marketo. So the view will be something like a DAG with a lot of parallel pipelines where you extract data from SFDC, transform them, and then wait for everything else to end in order to say that, okay, but the step for Marketo will be okay for SFDC. Am I right?
So I'm also another aspect, because right now the way how it's constructed is sequential. It can be run asynchronously, that you run extraction asynchronously to the modeling, or modeling has to run after extraction.
Modeling has to run after, yeah.
It depends on the extraction, because it takes, so what is missing from the description there is that we bring the data from the source and we store them in an intermediary table, intermediary schema. Then that data is transformed using SFDC, DBT, and they are transferred and loaded to our final data warehouse, which in our case at the moment, it's also a Postgres database, but in the future, it will be something different. So you bring the data, transform them, and load them to the final data warehouse.
I mean, why I'm asking, because Yanis mentioned about the extraction, and you mentioned that right now we run this extraction every 2 hours, but it's likely that some extractions we have to run more often or less often, and it kind of makes this process of modeling more asynchronous. That modeling will not depend on on data being extracted right now, but on the latest data that's been extracted, like a snapshot of the latest data. And this is kind of swap and replace process. I'm just trying to figure out the way how the pipeline is constructed, if there is like a way to make it behave differently, and how we could make it happen. So I'm trying to understand like all requirements and like the end goal that we want to achieve, not like the how it looks today, but like how it should look in the end to say that this is the way that it's supposed to work.
Yeah, I think today, does it make sense though what we want? Like today, we have, you can see we have Lever, Marketo, and NetSuite. And right now, if Lever fails, the Marketo is not going to run. That's the problem.
So like if Lever fails, Marketo extraction gonna run, but like DBT model will not run. That's the outcome.
Right.
And that's the
Right.
problem, right? So
That's
basically,
problem.
yeah, basically because DBT, if you look at the job, we actually run multiple DBT, essentially like jobs inside of this for different sources. And so you can see in some of these, you'll see HSCC, in other ones, you'll see the usage ping. And so basically,
So basically, we have DBT for each extraction, right? We have like DBT CI stats, we have DBT domains, we have DBT lever, right?
correct.
Yeah, should.
So what does actually do as FDC snapshot? It actually takes like the DBT result that is pushed to database and creates some snapshot of it, or is it still like CI stats, then CI stats DBT, CI stats SFDC snapshot?
Yeah, so the SFDC snapshot relies on the data that gets modeled by DBT in the modeling phase.
It basically, I believe the SSC snapshot tries to take like a historical snapshot, right? So because you want to look at some trends, and so this data can get changed over time, and so you want kind of snapshots to then use to see how things were looking a week ago, a month ago, and do some
we're going to be phasing that out though, so that's not a huge.
Yeah, but we want the SFDC update will stay, I think, because it's for contacting the SFDC. The idea there is that you have a step where you bring data in, you have a step where you transform the data in model phase, and then you have a post-processing step that you may need to do something in addition to loading the data warehouse. Now, at the moment, it's this snapshot or an update. You could have something more later on.
So how about we would like remodel this whole process into something different? It's still like, it's kind of hacky solution, but this is like definitely the direction we would go in terms of like extending the project, I mean GitLab CI, because this is also like one of the requested features of the fan in, fan out, and like multi-use support for multiple pipelines. I was, Joshua, could I share my screen like quickly? And this is like kind of like Tron idea, like maybe this is like something the simplest that we could do to make it like more useful. Okay, later. So I saw that we have like the first stage, there is like refresh dev. In second stage, we had like CI stats, lever, right? There was also lever. In stage number 3, we had DBT. And in stage 4, we have snapshot and something else. How about like we would remodel our GitLab CI? Is refresh dev something that is needed, or like what it actually does?
Refresh dev, what that does is we have it's required. Basically, it's just a step that copies the production database to the development database, and that's all it does, right? Because what we do is we want to have people banging around and doing dev work on the dev server, so they don't accidentally impact production.
So basically, like refresh dev, like copies each of these tables, right, separately.
Yeah, I mean, it's sort of a manual job that you use if you want to, force a new copy of onto dev.
Okay. So this is a manual job. It's not being like run automatically.
It runs. Think about, we use CI/CD for scheduling backups once per day. So that could be something different. So at the moment, refresh dev runs every day once and clones the production data warehouse to the dev data warehouse.
So like what I'm right now proposing, maybe we could like introduce the multiple pipelines concept into this, but like without having like multiple projects. This is something that we use right now like for GitLab QA. And we could basically, as part of single GitLab CI/YAML model, multiple pipelines, but make it more like doing kind of inception, that we execute from within the pipeline yet another pipeline, and we wait for this another pipeline to finish. So let's say that like this refresh dev would stay in a stage number 1 and it would be manual, but like in stage number 2, and like this would be like what would be differ. We have CI stats, which basically does like the current stats aspect. It's automated, and then we have the CI stats DBT, which is in stage number 3. Okay, it gets tricky because like we should disregard the names of the stages right now. But like the whole point is like that as part of this, like our single pipeline, we use variable expressions, and we allow you to limit what jobs are being created when you schedule yet another pipeline. So like, let's say that it would be workflow. This would be like the expression that if you have the variable named workflow CI stats, we will just create this job. If we have the workflow CI stats DBT, we will just create this job. And then like we basically would have like one main pipeline and a lot of small pipelines. And these small pipelines would basically have like this conjunction of jobs: CI stats, DBT, lever, plus lever DBT, and things like that. Or maybe like even single DBT, because as the workflow, we would also receive this information. But in our main like pipeline, we would have like CI stats workflow, which basically uses a GitLab API to trigger and to listen for these sub-pipelines in context of this repo. So it would be like trigger pipeline. It would be like CI. I don't know. Let's make it like let's say that this is like the name, but like the workflow would be CI starts and wait for pipeline, basically. And this would be like the pipeline ID returned. So that way, like you would be able to process all these workflows concurrently, but still like in schedules. And you could still like have some like jobs afterwards, would be like FD snapshot that could be executed after all these workflows to succeed. But like the processing of the model execution would be not blocked by the extractions of different workflows. It's not part of the product, like this is not integrated approach, but we use that already in the omnibus, and like if this would like solve your use case, it would give us yet another point to say that maybe this is something that we should support, like allow you to have this kind of inception workflow that like your main pipeline basically consists of multiple pipelines executed as part of the stage, because this small pipeline would be executed in the stage and would like have this kind of gated mechanism on the stage, but it would not block other pipelines from execution because they would be executed in parallel in this stage. Anyway, it's quite easy to model that today because there are like features for doing this kind of like expressions, and it could be like everything as part of the single GitLab CI/YAML, and it can be probably possible to write it very nicely. And I think that it will solve your need for now.
Great. Thomas, what do you think of that?
Yeah, that's pretty much what we're aiming for.
Great.
And we can set variables between those parallel pipelines, so we can set variables from one to the other.
Yes, like and these variables would be the pipeline created with these variables. These variables will be executed, will be injected in every CI job. So like you could have like the job which is not CI stats, but have like the model extraction job, and have another job which is like this DBT job that would actually like require you to have these variables set. So this actually gives you a possibility to manually trigger extraction and modeling of like one specific workflow, but also like as part of the master, you would execute this Uber pipeline that executes a lot of these small pipelines in parallel.
And if we want can we also add allow to fail and retry for those smaller pipelines as a whole?
Sorry?
So can we also do a trick and implement an allow to fail or retry for the whole smaller pipeline as a whole? So
yes, it would actually work that you can allow the sub pipeline to be failed and allow these to be retried if needed.
Okay, great. So the idea is that we will have something like, as an end goal, 50 smaller pipelines. So we will have our steps, 50 smaller pipelines, they're running parallel, and then we can have our post-processing steps that will gather results and decide how things went or whatever.
Not really like a post-process. This would be like you fire a main pipeline that as part of their job definition, it fires sub-pipelines. And you basically, as part of this job, you wait till these sub-pipelines do finishes. It consumes some resources because this is being executed by the runner. But like it's probably like small effort because you don't do it as post-process, but rather you make it the success of the job is basically the success or failure of this sub pipeline. So it's kind of like you go from the big pipeline to divide and conquer. You like try to split the big problem into a lot of smaller problems, and you watch for each of these problems how they behaved.
It sounds like that would solve our problems at least.
Yeah,
for sure.
One more question, but this doesn't solve the different schedule times for each sub-pipeline. Am I right?
No, because it does actually solve, because like it's possible for you then to have like schedule to trigger each of the workflows at given times, but you can also make it like schedule like the master all the workflows at like every 2 hours, for example. But you may say that I want to schedule like lever to be executed every 10 minutes, and this actually allows you because you model like specific workflows instead of like the whole project Meltano. So it actually allows you to have like separate schedules. And it kind of depends on how you model this Uber pipeline, because you can, for example, this Uber pipeline model in a way that you just look at the latest result, or you maybe not trigger, you just fetch a status of latest result scheduled with these parameters. So you are basically not limited by like the schedules, because you can model them any way they want. You can, for example, you may say that like some of this modeling happens more often, some happens less often, but like my Uber pipeline that is being run like every 2 hours or every 24 hours, basically like retries everything or like verifies the status and like retries them. I don't know about all requirements, but it gives like a lot of flexibility, because like you can model each of the problems separately.
So I think we're good here. Is there any other questions that we have?
I have another call right now, so I have to drop. I'm happy to help you how to implement that.
Let's talk in that CI channel that we created.
So maybe if someone would try to summarize this, is it like what I described is enough to summarize that, or do you need something else?
I think it's good enough for now. Yeah, we can summarize.
Yeah.
Can you update the airflow issue, Thomas, for now,
Yep.
so that we can at least document this for now?
So there is a question about how we do that we schedule the CI pipeline and we watch for the status out of the CI job. We have this example, and I can show you basically how it's being done quickly, because it's very simple. How I'm saying, like, it's not the most performant, but like it's something that would justify yet another time that this is like good to have that as part of the product. And so I'm posting on a chart. This is basically like the job definition for package and QA, which triggers and watches for the omnibus pipeline as part of the GitLab CE. And I'm looking right now for the scripts. Okay, it would be. It's not that easy. Commit shell scripts.
I'll be right back. Feel free to end this call if you guys are done. My dog will talk on my behalf.
Okay, I will link you on the channel later and show you exactly how it's being done by us in the package and QA.
Okay, Camila, I will post the question, your answer there, and we can continue there. And we will try to rewrite with Thomas maybe what he told us, so that we can see if we understood. Thank you very much.
So good.
Okay.
Thanks so much, Camille.
Let's talk later. Thank you.
Bye.